we are given an equation, and this is the equation of an ellipse. We just need to find all this information and graph. But actually, I'm going to graph first, and then we find those information later. Right. In order to graph, we have to change that to the standard form. So we're going to put 49x squared, and there's no x. There's y squared, and there's y. So that is the equation. We will do the complete in square to go to the standard form. 49x squared, it is already completed in terms of x. Y squared, we need to have a third term to complete the square. I'm going to add something to it, and we'll add something on the other side. Right. And to complete the square, we will take half of the middle coefficient, and then we will square half of 14 is 7, and we're going to square that will be 49, and we add on both sides. That's what we have. Right. Next, the equation will be equal to, we know on the right hand side it's going to be 49, and this will have the square for y, and that minus, so will be minus, and then we have 49x squared in front of it. It's almost in the standard form, except that we're going to divide both sides by 49, so the right hand side is equal to 1, because that is the standard form of the parabola. So what we'll do is divide by 49 on both sides. So we have x squared over 1 plus y minus 7 squared over 49 equal to 1. This is in the standard form. Right. From here we can see that the vertex, the center is going to be 0 and 7, because the standard form for an ellipse is x minus something square. That should be h. I should write h. This h over something square plus y minus k square over something square equal to 1. I'm not writing a or b here because that might involve the vertex. Whatever the biggest number will give us the vertex. But from here we see that h is equal to 0 and k is equal to 7. So the center will be 0 for x on the x component and 7 for y. So we have a center right here. Next, from this equation, we know the 1 is below the x squared. Square root of 1 is still 1, and square root of 49 is 7, and that is below the y. So the 7 below the y will go 7 unit up and 7 unit down. 1 is below the x, 1 unit left and 1 unit to the right. So we're going to have a very skinny box here, and the ellipse will fit inside this box. Should be inside that box. So it'll be like that. We see that the furthest point away from the center is going to be the vertex. So by inspection, we know that the vertex or the vertices, the two of them, x equal to 0, y is 14, and y is 0. So we have x equal to 0, y equal to 14, and x equal to 0, y equal to 0. So those are two vertices. 7 units up from the center, 7 units down from the center. We have the vertices. And then we just need to find 2 foci will be somewhere in here. It also align on the line with the center, the vertex, and the focus. What I should say is foci, vertices, and the center must be on the same line. Right. So the distance from the focus to the center is going to be C. So from the center to the focus it's going to be C, and in this case the bigger number 7 is going to be A and the smaller number is B. So A is 7. That's why we really don't need to put any A or B here. Just the bigger number is A and the smaller number is B. And the bigger numbers will stand by itself. So we have A squared equal to B squared plus C squared. So we can find C is equal to square root of A squared 49 minus B squared is 1, which is square root of 16 and square root of 3, or 4 square root of 3. So that's what C is, 4 square root of 3. Right, and then the foci. Again, the foci, vertices, and the center will be on the same line. And so from the center we go C unit up and then C unit down. So we're going to have 0, 7 plus 4 square root of 3. So 4 square root of 3 up and 4 square root of 3 down. And those are the two foci. And that's what we have. For this problem we have the graph. The center up and down 7 units give us the vertices. Up and down 4 square root of 3 units give us the foci. This is a vertical ellipse.